Before we look at separating axis theorem, I think it's better to understand what happens in a simpler case of collision detection. And one way of doing that in 2D games is using axis line bounding boxes, usually known as just AABBs for short. And what these are just simple boxes that are aligned to X and Y axis. So let's say this is one box, and then we have another box. This is A, this is B, and we have our axes, y-axis, x-axis. How do we find out if they are overlapping, right? So the first thing we do in that case is we project these boxes onto the x-axis, right? Project A, now we project B. This is B1, B2, and this is A1, A2, right? How do we know if there is an overlap? Let's look at these ranges. We can say we have A1, A2 as one range, and now if we want there to be overlap, it could be the case that either B1, B2 is overlapping from the left, or B1, B2 is overlapping from the right. Right? Now, we can just do a simple check that if either A2 is greater than B1, like so you cover both of these, B1, and then also A1 is less than B2, and we cover both of these cases, right? So we can check A1 is less than B2, and let me write it correctly. You can say and A2 is greater than B1, right? Now, what did we just do? We just projected both of these boxes onto x-axis, right? And then we also need to do that for y-axis. This is just implicitly known because it's easier to visualize like that, right? What happens in separating axis theorem? Well, it's the exact same thing, but we're also accounting for not just boxes, could be any convex polygon, and we're also checking not just the x and y axis, we are checking multiple axes, and we will look at how do we calculate which axis to check, and we are doing the exact same overlap check on those axes. And then if we find any axis that doesn't have any overlap, that means there is no collision, right? So like in this case, for example, if in this case we have both x and y axis overlapping. Now let's say B1 was right here, or wait, let me put it down here. It was right here. If B was right here, then we know that there is overlap on the x-axis, but there is none on the y, right? Because we have this line here separating both of those boxes. Let's say this was B prime, right? So we do the exact same thing for convex polygons. It's just that we no longer have just the x and y axis, we have multiple axes that we need to check. And we will take a look at how do we find those axes. So let me just clean this up. Okay, so now let's say we have two arbitrary polygons, convex polygons, and we will take a look at why it's only convex polygons. Let's say we have this one, and then we have some square. I'm just gonna rotate it so it doesn't look like a bounding box. Let's say it's like that, right? Whatever. Now what did we do in the case of bounding boxes, axis aligned bounding boxes? We just checked x and y axis, right? Now in this case, it's obvious for us to see that there is a separation in between these two, and then let's say we just draw one line here. We can see that this line does separate these two polygons, right? We can have another line, we can have another line, it doesn't matter. Now these are actually not just lines. We can think of it as what we did in the case of bounding boxes was we project them onto the x-axis, right? You can think of it as someone using a flashlight from the top, and then these polygons casting a shadow at the bottom, right? It will be a shadow here, a shadow here, right? Now we end up with these two ranges, and we do the same thing we did for the axis line bounding boxes. We check if there is any overlap. If there is no overlap, there is no collision, right? But it could be, now we have another case. Let's say we have two different polygons, right? And now checking x and y axis isn't enough to see if these are separated, right? Now in this case, what we need to do is we need to use our flashlight from this direction. Only then we can find a way to project the shadow here, right? Only in this case that we know that there will be no overlap. So overlap for the first one is here, overlap for the second one, the projection for the first one is here, and the projection for the second polygon is here, right? And there is a separation in between, so there is no collision on this axis. There's no collision for these two polygons, right? Now the difficult part is just finding out this axis, right? Where to use the flashlight from. And what we usually do is we just look at all the corners, right? We look along the edges. So we will use a flashlight from this side, we'll use a flashlight from this side, flashlight from this side, from this side, and same thing for the other polygon. Right? And by doing this, we know for sure that we are checking all different ways, or all different axes that we need to check to guarantee that we are covering every possible way this polygon could be colliding, right? Now, for all of these axes, you need to look at all of them. You just need to validate that if there is any single axis that you can find that does not overlap, right? Any single axis where the projections don't overlap, then you know for sure that there is no collision, right? And in this case, with our two diagrams, is this specific way to project, right? So the axis would be this one, right? So what is this axis? This axis is actually just the normal of this edge, right? So let's say if this vertex is A, or we can say, sure, if it's A, and then we have this vertex is B, then this axis that we need to project onto is just the normal of A to B, right? Now, what are we projecting, right? We are projecting each vertex of both of these polygons. We are projecting each vertex of both of these polygons onto this axis, right? So we will be projecting this vertex, this vertex, this vertex, like that, right? And we need to use the biggest range that we can use that covers the whole projection. For each polygon, we track what's the minimum and the maximum of that overlap of that projection, right? So for, let's say, this polygon is P2, this is P1, right? For P2, you need to say P2 min and P2 max, right? That's the shadow or the projection. And then we have P1 min and P1 max, right? And we just check these projections if there is any overlap, and we need to do that for all axes. So what we want to do is we want to find the projection of each vertex, just like we did for the axis line bounding boxes. We have each vertex of these polygons, right? So if I draw that out, we have this one, we have this one, for example, right? v1, v2, doesn't matter. We have a vector that points to the vertex, right? And then we want to do a dot product with the normal, which is our axis. This is this one is the same thing as this axis at the bottom, right? And how do we find this projection? Well, let me just move everything to the side. We just do, let's say we have two different vectors, A and B. We can just do a dot product between them, and dot product, it just gives us magnitude of A, magnitude of B, cosine of the angle between them, right? We don't care about the angle or anything in this case. We just want to know a scalar value that gives us the projection of one vector over the other, right? So let's say you have two different vectors. Let's say you have two different unit vectors. It's easier to understand. Then basically the projection of A on top of B is simply A dot product B, right? And if they are unit vectors, then it's simply the value of cosine theta, right? Which is what you usually get if you were just doing trigonometry and then you had an angle theta here, right? And yeah, that's pretty much it for the projection. We do the same, we gotta do the same thing for each axis for both polygons, and then if we find any axis that has no overlap, then we can just say there is no collision between the two polygons, right? And for our game, we just just need the collision detection. We are not going to do collision response, which basically means that what happens after the collision. In Asteroids, we just destroy one or the other entities, and then that's it. But in, like, if you're building a physics engine or have something in a game that collides and then reacts to that collision, maybe you want to bounce off of each other, then we gotta do a bit more work. For us, it's just simple collision detection. So that's everything for the SAT, right? I'll also go over the high-level summary next time when we do the code implementation. Yeah, that's surprisingly, the code for SAT is actually pretty minimal. I would say it's even simpler to understand than the point in polygon collision. It's just that sometimes you get confused by, like, oh, what should be the projection and how are you finding these axes and things like that. But like, as I like to understand it, is just it's a more general case of axis aligned bounding boxes. And if you just use the flashlight analogy, I think that helps understand why we are doing the projection overlap check. Now, if you're still confused, I think it will help when we go over the code to understand what exactly are we doing. And I'll also link this article in the description below, which goes into even further detail, and it also does collision response, which we don't really need, but is still a good read otherwise. So I highly suggest going through that as well. Okay, that's everything for today's video. Thanks everyone for watching. We'll do the implementation next time. See ya.